Hi, my name is Azrin Alif bin Karun Nizam. My number matric is 20201057. Uh, Today, we're going to present about first wave microelectronic. These are my members of Group 5A. We got Hani Farisha, Muhammad Izzat Shabil, Nur Shahira, and Yashodan. For the introduction, the first technology wave, which began with the creation of the transistor, is microelectronic. A transistor is a semiconductor device that amplifies and switches electrical impulses and power. Silicon and germanium are used to make microelectronic devices. In microelectronics, there are etching and masking processes as well as doping processes. Silicon is a good semiconductor material because it allows you to change the electrical characteristic of it by introducing impurities. Moore's law is crucial in the first technology wave. Moore's law asserts that every 2 years, the number of transistors on microchip doubles. Okay, I'll pass to Nur Shahira.
Thanks, Azrin. Background history. Okay, this is the diagram of first transistor in Bell Labs in 1947. First wave has discovered an invention, namely transistor. The first transistor used two closely spaced gold contacts pressed onto the surface of a slab of higher purity germanium. Inventing the transistor in 1920, scientists proposed building amplifiers from semiconductors, but they didn't understand the materials well enough to actually to. After that, William Shockley at Bell Labs revived the idea as a way to replace vacuum tubes. In 1947, under Shockley's direction, John Barden and Walter Brattain demonstrated the first semiconductor amplifier, the point contact transistor with two metal points in contact with a silver of germanium. Inventing the transistor, in 1948, Shockley invented the more robust junction transistor built in 1951. Marvin Kelly, who was the then head of Bell Laboratories, had brought the two together. Kelly believed that working with such an unknown group of materials as semiconductors demand a combination of different specialties. The brilliant theorist Brattain, the skilled materials expert Barden, and the very accomplished experimentalist Shockley, who was also strong on theory. The objectives for the project were very general. In 1949, the transistor was created by John Barden, William Shockley, and Walter Brattain. This is the figure of John Barden. Okay, I'll pass to Dahani Farisha.
Next, Barden and Brattain's transistor that worked. Barden and Brattain's transistor consisted of a silver of germanium with two closely spaced gold point contacts held in place by a plastic wedge. They selected germanium material that had been treated to contain an excess of electrons called n-type. When they caused an electric current to flow through one contact, called the emitter, it induced a scarcity of electrons in a thin layer, changing it locally to p-type near the germanium surface. This changed the amount of current that could flow through the collector current. A small change in the current through the emitter caused a large change in the collector current. They had created a current amplifier. This is the elements of Barden and Brattain's transistor. Next, first planar transistor technology, 1959. On August 1959, Fairchild Semiconductor Director of R&D, Robert Noyce, asked co-founder Zay Luss to begin development of an integrated circuit based on Cornish Planner process and Noyce's patent. Nobel Prize 1956. Barrett scientists John Bardeen, Walter Brattain, and William Shockley won the 1956 Nobel Prize in Physics for their invention of the transistor. Nobel Prize 2000. Jack Kilby from Texas Instruments was awarded the 2000 Nobel Prize in Physics for his part in the invention of the integrated circuit. Jack Kilby is being rewarded for his part in the invention and development of the integrated circuit, the chip. Through this invention, microelectronics has grown to become the basis of all modern technology. This is the picture of first IC device invented by Jack Kilby.
Okay, next up I'll explain about the applications of microelectronics. Innovation nowadays seems to be centered on information and communication systems. First of all is microelectronics. There is no dispute in the fact that microelectronics has been a key driver of the scientific and technological process that has been made major contribution to the social and economic growth of mankind since the mid 20th century. Microelectronics have played important roles in humanity and other sectors as well, such as mobile phones and telecommunication system, multimedia application and digital media system, computing and networking, cleaner production processes for factories, vehicle safety, and finally, better performing medical systems. There are many examples of microelectronic application. Here are the few. First, flexible electronics. The technology presented by flexible electronics makes it possible to easily implement new applications that were sometimes not feasible to attain before now. This includes applications such as smart tactiles and informative human interfaces. Secondly, green electronics. The push by the government for green manufacturing is a driver to innovation in microelectronics for product design. This technology incorporates power-saving capabilities, eco-friendliness, such as reduced carbon emission using microelectronics. Next up, I'll pass to Shabil.
Okay, thank you, Yashudan. Okay, now I will explain to you and present to you about the future trends of microelectronic wave. Okay, the first thing first is the limits of physics. Like the past century, as we can see the evolution of physics research until now. Year by year, more new research and new methods in microelectronic research being found and keep growing big. In the future, I believe there will be more of new research will be found that can make the microelectronics industries achieve new things. Okay, the next thing is working towards micro nanosystem. As we can see in microelectronic nowadays just has calculations and memory only, and just by that we cannot achieve more than now. Okay, in today we have only nano system, so in the future maybe we can have the micro nano system. Moreover, we may add functions to a circuit using components such as sensors, switches, radio communications, power electronics, energy recuperations, imaging, lightings, and other choice. This enables the creation of micro nano system capable of accomplishing complex tasks. By introducing new concepts that do not rely on the traditional CMOS transistors and the silicon-based microelectronics, it should be possible to develop less expensive options. Several possibilities include spintronics, nano-electromechanical structures, molecular electronics, and quantum electronics. Okay, I think that's all from me and from my teams. Thanks for giving us the chance to present to you and explore more about the first wave of the about the microelectronics. Okay, thank you.